Okay, so like I said, today we're going to do a quick review over graphing systems of inequalities. Okay, so this should be super straightforward. We're just going to review a couple things, and then you'll be able to get started on your homework. Okay, so before we can graph systems of inequalities, or even a single inequality, we have to remember, when do we graph a solid line? Yeah, when you've got the equal to, greater than or equal to, or less than or equal to. And when do we graph a dotted line? Good. So solid line is with the equal to, dotted is without the equal to. When do we shade above a line? Yeah, you shade above with greater than or equal to. And we shade below with less than or equal to. Okay, so just a little review of that. So let's look at number 1. First thing I'm going to need to do here is solve both of these equations for y. So when I solve this first equation for y, what's going to happen? Minus 2x on both sides. So I'm going to have y is less than or equal to negative 2x plus 4. All right, what's my y-intercept there? 4. What's my slope? Negative 2, so down 2 over 1. All right, is this a solid line or a dotted line?
Solid.
Solid, because of the equal to. All right, are we going to shade above the line or below the line? Below, because it's less than. Okay, let's go ahead and do the second one. I would move over the x, so I would have 2y is greater than or equal to negative x plus 8. So then y is greater than or equal to, when I divide by negative x by 2, I get negative 1/2 x plus what? 4. So again, what's my y-intercept? 4. And what's my slope? Yeah, negative 1/2. So down 1 over 2. 1 left 2. Solid or dotted? All right, and which way would I shade? Above. Okay, so remember, to a solution for a system of inequalities, your answer is not a given point. It's a whole region, right? So where is the solution region? Yeah, where the shading overlaps. So where the shading overlaps. In this case, are the lines themselves solutions? Yes. Why? Good, because they're solid. Okay, so any point on this line is a solution, any point on this one's a solution, and that intersection point is a solution. So what's one point that we could name that would be a solution? There's lots, obviously, but negative 2, 6. Yes, I agree with you. Okay. And that's pretty much all we're doing today. Okay? We're just reviewing this. So let's look at number 2. All right, y is less than 3. What kind of line is when we just have y and a number? Horizontal, hoi. So we go to y equals 3. Is this going to be a dotted line or a solid line? Dotted. Shade above the line or below the line? Below, because y is less than 3. All right, so let's go ahead and solve this one for y. What would we do first? Minus 8x, so this would be negative 4y is less than minus 8x plus 12. And then what? Divide by negative 4. What happens when we divide by negative 4? Yeah, you've got to flip that sign. So this is going to become y is greater than positive 2x minus 3. So let's find our y-intercept of negative 3. Slope of positive 2. So that's up 2 over. Is this line solid or dotted? Dotted. Shade above or below? Above. Why? It's greater than. All right, so where's our solution region? Yeah, it's all this part where your shading overlaps. All right, so give me a solution. 0, 0, negative 4, negative 1. Those are good. Tell me, is this point right here, 3, 3, a solution? No, why not? Good, those lines are dotted. So 3, 3 would not be a solution. All right, let's look at number 3. All right, let's solve that top one for y. So it's y is less than or equal to negative x minus 2. What's our y-intercept? Negative 2. Our slope is negative 1. Solid line or dotted? Solid. Shade above or below? Below. Okay, let's look at the next one. X plus y is greater than negative 2. What happens here? Well, when we solve for y, we get the same equation, right? Okay, so I'm going to graph. It's going to follow the same points, but is it solid or dotted? Dotted. And which way do we shade? Above. Okay, so this is kind of strange. Do the shadings ever overlap? No. What about on the line? Are points on the line a solution to the system? No, why not? Yeah, one's dotted and one's solid. So what do we know about this system?
No solution.
Yeah, there are no solutions here. Okay, because any solution has to satisfy both inequalities, and that wouldn't work. Okay, skip down to number 7. All right, label the solid line A and label the dotted line B. All right, and take a second and come up with that system of inequalities. Start by maybe finding your slope and your y-intercept of a line. All right, so let's look at line A. On line A, we have a y-intercept of 3. And what's our slope? -1. Good. Down 1 over 1, down 1 over 1. So our slope is -1. So y is this a solid line or dotted? Solid. So we know we're going to have an equal to. Are we shading above this line or below that line? Above. So y is greater than or equal to -1x plus 3. Everyone see where we came up with that? All right, what would be the inequality that represents b? Y is greater than 2x minus 3. Everyone cool on that? All right, flip to the back for me. All right, take a sec and read that situation. All right, so what are our variables? X represents what? Hours mowing, and Y represents hours raking. So total, he cannot work more than 15 hours per week. So how would I represent that? Or equal to what? 15, thank you. All right. Our other inequality is going to have to do with money. He wants to earn at least $120 per week. So how would I represent that?
The 12x plus 6y has to be equal to...
At least? How would we represent at least?
Greater than.
Good. Greater than or equal to 120. All right, so let's solve this green one. That would be y is less than or equal to -x plus 15. So let's find 15 on our graph. And what's our slope? -1. All right, that line is going to be solid or dotted? Solid. Hopefully your line is a little bit straighter than mine. Shade above or below? Below. All right, let's solve the pink one. 12x plus 6y is greater than or equal to 120. So 6y is greater than or equal to -12x plus 120. So that means y is greater than or equal to -2x plus 20. That line's also going to be solid. I'm going to shade above that line or below that line? Above. So that would mean that our solution region is this piece in here, right? Right, so it says if Jamal decides to mow for 11 hours, what is the maximum number of hours that he could rake? So find where you see 11 hours on the mowing axis, right here. What's the maximum number of hours that he could rake while still being in our solution region? 4. Because that's a solid line, right? So that would be 4 hours. If Jamal decides to rake for 6 hours, so where am I going to find 6? On the y-axis. What's the minimum number of hours he would need to mow? It's going to be 7. Careful with your points right there. You could also get these by plugging your values in, right? You could plug in 6 for y and solve. You could plug in 4 for or 11 for x and solve, and that would work too. But the graph's there, so I'm going to use it. Okay? Alrighty. That's it.